So next topic we're going to cover in this course is on linear inequalities. Okay, we're going to deal with inequalities throughout chapter 4. And so the main thing with inequalities, they're actually very similar to equations, and the way we're going to solve them is similar. I'm hoping a lot of this is review for you, so I won't go into a lot of the details as to why things work the way they do. But when you have a linear inequality, that's an expression that involves either a greater than or a less than or a greater than or equal to or a less than or equal to symbol, then when you're including those four things and you're solving an inequality, you're basically doing the same stuff you would with an equation. You're adding the same amount to both sides, or subtracting, or multiplying, or dividing the same amount from both sides. And so most of what we're doing is the same as solving an equation, but there's a couple exceptions to that. There's a couple little tweaks that you need to, they seem little, but they're actually very significant, and there's some reasons why they occur. First of all, with equations, you can just change the order, interchange the two sides, and the equation is still true, right? So if I had like x equals 5, I can change the order and say 5 equals x and nothing happens, right? With inequalities, that is not true. Think about it for a moment. If you take the inequality 2 is less than 7, well, we know 2 is less than 7, right? It's to the left on the number line. But if you interchange the order there, it changes the inequality symbol to a greater, right? 7 is greater than 2. I wouldn't keep the less than symbol, it wouldn't make any sense. And so when you're ordering things, if you change the order, you have to change the symbol as well. That's an important thing to keep in mind, because there may be times where you solve a linear inequality and you end up with something like negative 8 is greater than or equal to x, but it might make more sense to you to have the x on the left side, in which case you'd want to flip everything. And so you may say x is less than or equal to negative 8. These two inequalities are equivalent. They have the same values as solutions, okay? So interchanging the sides of an inequality means you must change the inequality symbol from a greater than to a less than, or vice versa, okay? So that's the first thing you have to keep in mind. So I'll summarize these up here on the right. Change the symbol when interchanging sides or switching sides. Okay, so change the symbol when switching sides. If you switch the sides around, you have to flip the symbol as well. Okay, so that's the first thing. Second thing to keep in mind, and just very basic description here. If you had two numbers on a number line, let's shrink that up. If you had two numbers on a number line, let's say I had the numbers 5 and 8. I know that 5 is less than 8, right? If I were to add the same amount to both sides of that inequality, it's like adding the same amount to both of those numbers. It moves them down the number line, but it keeps them relatively the same, right? The same one is still smaller. So if I were to say add a 3 to both of these, I'd have 8 less than 11. I know that by shifting things around, it doesn't flip their order, so my inequality stays the same. Same with subtracting, and really same with a lot of multiplying and dividing. The only exception is going to be when we multiply by a negative number. Now think about this for a moment. If I again start with the inequality 5 is less than 8, let me redraw this. I'm going to throw the 5 and the 8 a little further off to the right here. I know that 5 is less than 8. If I were to multiply each of these values by -1, for instance, so times by -1 times by -1, I'm going to end up with a -5 and a -8. Well, think about where those two numbers are on the number line. Well, let's put a 0 in here somewhere. 5 and -5 are equal distance from each other, but on either side, I'm sorry, equal distance from 0, but on either side of it. Same with the 8. 8 and -8 are an equal distance from 0, but on the other side. And so what ends up happening is the -8 is actually less than the -5. -5 is greater than -8. And so essentially when you multiply by a negative number, it takes the two numbers and interchanges them on the other side. It's the mirroring effect of the positive and negative numbers on either side of 0. Okay, and it works the same. It doesn't matter if you have two positives and you end up with two negatives, or two negatives and end up with two positives, or you could even have a negative and a positive and end up with the other one being negative and the other one being positive. They're still going to switch places on the number line when multiplied or divided by a negative number. I just used -1 as an example. It works for any negative multiplication or division. Okay, so the other kind of weird scenario that doesn't follow the linear property, the properties of equality. The other exception is that you change the symbol when multiplying or dividing by a negative number. Change the symbol when multiplying or dividing both sides by a negative number. Okay? So that's going to be key. Those two items you have to keep in mind when solving inequalities. Okay? Let's look at an example here, or a couple examples. We'll see where maybe some of these play out. Let's look at something like -2 times x plus 5 is greater than or equal to x. Let's go with a minus I don't know, 13, something like that. I'm just making something up that might work out nicely. And so on this one, I'm going to first, we're going to solve it as though this was an equation, except for these two properties here we got to keep in mind. So I'll just solve it using distributive property, just like I would an equality. So -2x minus 10 greater than or equal to x minus 13. I might choose to put the x's on the left side and the constants on the right. And so I have, I'm going to subtract an x from both sides. Well, remember subtraction. When you subtract from both sides, the inequality symbol stays the same. It doesn't change anything. Okay, so I get -3x minus 10 greater than or equal to -13. Then I might add the 10 to both sides to free up the variable here. So add 10. Again, addition does nothing to change the inequality. Stays the same. So -3x greater than or equal to -3. Worked out kind of nice. And then to free up the x, I've got to divide by the -3. Well, here's where we have an issue. If I divide both sides by -3, this falls into this category here, the second property, where you must change the symbol when dividing both sides by a negative number. I'm dividing by -3, so I've got to change that symbol to a less than or equal to. And I end up with x less than or equal to 1. Okay? Well, this is an interval now. When we're dealing with inequalities, we're actually going to use solution sets as our answer. although solution sets might get a little clunky to write out these in set form, you could also write them out in interval form, and you could even throw them on a number line. Your textbook is going to, or your My Math Lab, generally is going to want these in interval form, but I would accept them in any of those forms, and I'll show you the solution set and the interval form as I go through these examples. So the solution set is not too bad. You would just take, you know that your answer is going to be x values, so we're going to put x such that, and then you put this inequality as the property that they have. It's all values of x that are less than or equal to 1. There's the interval form. I'm sorry, the set form. Now, on a number line, I always use a number line to help me out. There's the number 1. I'm going to shade in everything to the left of 1 because I want x to be everything less than 1, right? X's are over here on the left. And so I'm going to shade to the left, but I also want it equal. Okay, so 1 is included. So I'm going to use a bracket on the 1. We learned this back in chapter 1 when we dealt with intervals and inequalities a little bit. So we're going to work on the left here, shade to the left. And so that helps me to visualize what my interval form is. My interval form is going to have a left endpoint at negative infinity and a right endpoint at 1. On the left, the negative infinity, they're never included, so I leave a parenthesis there, but the 1 is included because of the equal sign here. We want to include that endpoint, and so I put a bracket on the 1. This interval is, I believe, what my math lab is going to accept, and so that's probably what we'll stick with, but I want to show you all of the different forms that a solution could take. Okay, let's try another example here. Okay, here's 15 is less than 4 times x minus 3. All right, again, I'm going to distribute the 4 to simplify the right-hand side. So 15 is less than 4x minus 12. Then I'm going to isolate the x term. So I'm going to add the 12 to both sides. I get 27 is less than 4x. I can do that. I can add to both sides and not change the inequality. And then here I'm going to divide out the 4. Now remember, dividing by a positive number is okay. I don't have to divide, I don't have to switch the inequality like I would with a negative. So I'm going to leave that as a less than. 4's cancel, I get an x on the right. And 27 over 4 is an improper fraction. It is simplified. So I'll leave it as 27 over 4. But if you wanted to put that in as a mixed number, you could. It's what, 6 3/4 or 6.75, I believe, if you put that in as a decimal fraction, a mixed number or decimal. Doesn't matter to me, but I kind of like the improper fraction. On my math lab, just pay attention to the directions. It will tell you what form it wants it in, whether it's a fraction or a mixed number or a decimal. I'll leave it as an improper fraction, that's fine. And so my set builder form for my solution set, oh, there's one other thing I want to point out. Generally speaking, it's easier to work with these inequalities where the variable is on the left side. And for that reason, I'm going to move the x over. I'm going to interchange the sides here. When I do that, though, remember, property 1 says I must change the symbol when switching sides. So the less than now becomes a greater than. And so what I've done is when I read it with the variable on the left, it makes more sense that x is greater than 27/4, which means it's to the right, okay? Now when I put this in set form, I just put the inequality in. It doesn't matter which one I use, the one with the x on the right or left, it won't matter. I just put x such that, x is greater than 27/4. That's fine. Now when I look at the number line in the interval, that's where the distinction between these is a little bit important here. I'm going to set this up with a 27/4 in the middle. Now again, it's 6.75, I believe, but I'm just going to leave it as 27/4. I want to, because when I read this, it's x is greater than 27/4. That's going to be everything to the right? The x values are greater. So I want to shade that to the right. I want to exclude the endpoint because there's no equal sign in this inequality. So I'm going to use a parenthesis on the 27/4. Therefore, my interval form is going to have 27/4 as the left endpoint, infinity on the right. The 27/4 is excluded, so I want a parenthesis there, and infinity is always excluded, so we get a parenthesis there. Now, one thing I want to point out is that when you have the variable on the left in your solution at the end here, the direction of the inequality symbol will point in the direction that you need to shade on the number line. It's just a nice feature that corresponds the visual here of the number line to the inequality, okay? It only works when the variable is on the left. Okay, so variable on the left, the inequality symbol looks like the arrow you got to shade, in this case shading to the right. All right, so that's just a nice way to correspond those two. Or you can just think it through. If x is greater than 27/4, it needs to be to the right. Okay. Yeah, so I think that pretty well covers the different topics in this first section in chapter 4. Just getting the fundamentals of solving inequalities down, the two properties here that are different from equations, and then just how to represent your final answer in the set form, the number line, or the interval form.